The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon and welcome to today's webcast, brought to you by Security Systems News and in partnership with the Security Industry Association. Today's event is Connecting Smart Cities, Intelligent Video Surveillance. I'm going to turn it over to Mia Smith of the Security Industry Association to introduce our sponsors and our panelists. So Mia, it's all you.
Thanks, Tim. Our sponsors today are Access Communication and Ciclu. Access offers intelligent security solutions that enable a smarter, safer world. As the market leader in network video, Access is driving the industry by continually launching innovative network products on an open platform, delivering high value to customers through a global partner network. Access has long-term relationships with partners and providers and provides them with knowledge and groundbreaking network products in new and existing markets. Ciclu delivers multi-gigabit fiber-like wireless connectivity in urban, suburban, and rural areas. Operating in the millimeter wave bands, its wireless solutions are used by leading service providers and systems integrators to provide 5G fixed wireless, used in safe city, smart city projects. Thousands of carrier-grade systems are delivering interface-free performance worldwide. Easily installed on street fixtures or rooftops, the price-competitive radios have proved to be ideal for networks requiring fast and simple deployment of secure fiber-like and future-proof connectivity. Now on to our speakers. Today's first speaker will be Steve Safaro, followed by Ciclu's Alex Thornton. Steve brings over 30 years of security industry experience to his role as Access Communications Industry Liaison. Among the leadership positions he currently holds are Chairman of Security Industry Association's Public Safety Working Group, where recommendations are developed to improve safety, security, and sustainability of cities and communities. Steve also holds Chairman of the ASIS Security Applied Science Council and Standards Team Leader of the DHS and S&T Video and Quality Public Safety Group. As subject matter in physical and cybersecurity solutions, Steve has expanded his focus to include forensic video, predictive and prescriptive analytics, IoT, security automation, and much more. Steve is published in a wide range of security publications and delivers over 100 industry credit sessions each year. He is also author of the Digital Video Handbook, a Department of Homeland Security Science and Technology publication, providing guidance for law enforcement, fire, and other first responders. Now on to Alex. Alex Thornton is a seasoned security professional with over 20 years of experience working in the global security market. Alex has held business development, sales, product management, and marketing positions with major video surveillance manufacturers, including Pelco and Norbain, IQ Envision, and Intransa. In his role as Director of Development and Sales for Security Surveillance at Ciclu, Alex is responsible for growing Ciclu's business globally, with particular focus on meeting the demand of fiber wireless network connectivity for surveillance applications. Now back to you, Tim.
Yeah, thanks very much. I'm going to get started here, but before we do, I would like to do a quick poll question. There's going to be 3 poll questions to the event, and I'd like just to throw one out to you right now. So if you can bear with me 1 second, let me select the poll, launch it, and let's see what we got. Assume you all see that.
So we can read it off to you. You got it right there, right? What technology and service will have the greatest impact on public safety, right?
Exactly. Thank you, Steve. All right, they're coming in. And we are going to close this interesting numbers. All right, I'm going to close it, and then we're going to show you what we got. And let's share.
Yeah, that's very interesting.
So you all seeing this?
Yeah, this is this is very telling because lots of people really understand that the wireless gigabit transmission systems, we wouldn't be able to do most of the projects in smart cities without them. And in fact, you're going to see a little bit of a case study on the Super Bowl Live event. And Alex, right? You were right there with us. And actually, without your, what do we call them? The wireless bulldozers. We wouldn't have been
that's right, the wireless bulldozers.
Right. We wouldn't have been able to get as many streaming video channels over to first responders as much as possible. And one thing I do want to mention is that this is very consistent with the trend that we're seeing in the industry for social media monitoring, geofencing. This is very much apparent in virtually every public safety and sports arena market. So what you're taking a look at right there is kind of an overview on the ideal safe city, just the components. Now, what's kind of safe and smart city, I should say. In any safe and smart city, what's interesting is they typically have four major components. One being the infrastructure, which candidly, in my opinion, it's probably the most important thing. Next being the sensors, which I also think are extremely important, being a sensor manufacturer, of course, but also because there are just so many sensors that are available. And then energy and the ability, the socialization, so to speak, or the ability for people to experience good things and productivity and be able to exist in a most efficient way in cities. One thing that's very interesting is that in the real, probably one of the biggest applications, and those of you that are systems integrators on the line and security consultants and practitioners really already know this, but smart cities, probably the biggest opportunity is in intelligent transportation systems, because one of the great things about smart cities is that they attract people. And what kind of a city will attract you, but one that you can do business with easily and travel to and from very, very easily. So let's see if you can just advance this slide. Okay, I got it now. All right, I see. I was just hitting the virtual button. So this is an example. What you're seeing here is some pictures that we took during Super Bowl Live of Houston growing into a smart city. And what we've actually done was we did a public and private partnership project together with partners like CCLU and the City of Houston, their Public Works Department. And unlike, I would say, in a lot of cases, the commitment to pilot programs in our industry has been one that it's done and then it's over, and typically the equipment might get scattered around for other purposes. In our case, in the City of Houston, I'm really happy to say that they are repurposing the equipment to grow into a smart city, and it's going to be in two specific areas. One that is in their downtown area, Discovery Green, and what you're seeing there is Discovery Green on the right-hand side. And on the left-hand side, you're seeing the Emergency Operations Center, where it's also going to be consolidating views of even the uptown area. That video wall, very, very cool place, right, Alex? It's a very, very amazing wall. It has very timely the Weather Channel there. It even has the hospital census, where the boots on the ground, the assets that are on the ground, traffic. And right next door to this Emergency Operations Center is Houston's Next Generation 911 Center. So two really amazing facilities right in one.
There you go. About being partnered with Verizon because they gave us access to their cloud. We're doing straight link into our public safety video network, which is a closed system. Access Cameras was able to do two streams of live video. But one stream went into our closed system, the other stream went into their cloud. And what that allowed us to do is share with other partners outside our footprint, because you got to have a specific workstation to view the public safety video network, and you can't put those workstations everywhere. So having access to the Verizon cloud gave his operation access to the camera, so they could do their
So
job.
that's an overview on the system deployed in Super Bowl Live. And what was interesting was they set up these virtual command centers right in the George R. Brown Convention Center. And what's interesting is, after the hurricane, that became a shelter. But during that Super Bowl Live event, you can actually see a picture of the main stage before and after the actual concert that they had. Over 10,000 people. And during this concert, something was very interesting. There was the Seekly radios on top of an Overwatch camera. What you're taking a look here is pictures from the Overwatch cameras, which were both visible light and thermal imaging. And one of the really amazing uses of thermal imaging was the ability to see the outlines of individual people. So it wasn't a question of having a lot of pixels on the target, but it was allowing the emergency response personnel to be able to see where people were, and they actually were involved with a medical rescue during that event too. So it was very interesting and unexpected, and it was great that they made use of the solutions. And probably one of the greatest things was that they had real-time video beamed everywhere, with your wireless fiber, Alex. And one of the interesting things, if you heard Jack Hannegriff with the City of Houston talking there earlier, they needed to stream the video to both the Emergency Operations Center and to the Verizon cloud. And I remember we were on the first phone call, and people were talking about integration, but sometimes the simplest of solutions are the best. And what we said was, why don't you just take 2 streams out of the camera and stream it to both locations? And it worked out so very well. Entry screening was, yeah, please.
Steve, I got a quick question. Talking about Houston, you have, as they're repurposing what they had for the Super Bowl into a smart city, what's the impact on that with the hurricane? What did Harvey do to that infrastructure, and where does it stand today?
Oh, it's still there, and obviously Houston has been very much focused on their recovery efforts, but the equipment is still there, and in process of the 2 focused areas, one which is an uptown area and one which is downtown. And one of the areas uptown is near the Galleria district, and what they're going to do, they're going to be lighting up a wireless network, which is still in place. It's wonderful. And beaming video across buildings and collecting video from traffic conditions, both on the highway, be able to do traffic incident management, as well as traffic flow. So we'll be able to get some really amazing data from that and be able to plot that out over a period of time.
Right, okay.
And that entire pilot project, you can actually see an overview of this pilot project. And what you're seeing here is Discovery Green, and you can see these general areas where we have analytic processed groups. And largely, a lot of this you might associate with safe cities, but a typical smart city function, one of the applications that we're going to be using is Agent VI's crowd detection and pedestrian activity. So one typical application might be the light rail system that's nearby. Crowds can be detected, and then an alert, perhaps over at the Toyota Center, a concert got let out early, and the city will have the capability of being able to detect crowds converging on the light rail system and be able to dispatch additional equipment, which is really kind of nice system. And that is a great example of, making it smarter. We have some of the, I'm not going to say traditional, but some of the more traditional solutions that are going to help, like loitering, vehicle stops, pedestrian activities, but sound, acoustic signature detection and sound monitoring without recording and maintaining privacy is going to be an important aspect. So that's going to be able to do gunshot detection and aggressive voice detection. What you're seeing in this image is actually the Uptown Galleria District, which is home to, what is it? I think it's about 1 million people, or 500,000 business people and businesses. And it's an amazing area that attracts both upscale shoppers, but also a great number of businesses. So it's kind of like a little city within a city. So we'll be doing a good deal of different analytics there. One of the things that we're going to do is license plate capture and recognition. So it's going to be possible within a corridor to be able to read a plate, maintain privacy, and then read that plate again as they leave the area. So you can get a real-time piece of throughput data without having to use like a Waze or a Google Maps, which essentially is getting data off of your smartphone and dragging down its battery. So these sort of things are the wave of the future. You're going to see in probably about 2 years, many cars, especially in the high-end vehicles, are going to have the capability of doing V2V, or communication between vehicles, but also being able to directly send traffic speed information directly to collection devices all along the highway. So we've got a great opportunity to explore a lot of different windows to intelligence. Whether they're critical infrastructure areas, and I showed you the downtown area before, with a particular reason that one of the areas that we're going to be on a path to protecting is a power substation there. So some of these goals might include reducing security investigations. It might be reducing energy management. So in other words, actually leveraging sensors, to leverage and not waste resources. So one of the things that really, I know you mentioned, Tim, the hurricane events. Recently, one of the things that really struck me was this country is have a very spotty deployment of intelligent transportation systems. I think you may have seen what's known as contraflow used in a recent tropical storm or hurricane, I forget which, in North Carolina, where they made use of opposite lane flow to get people out and away and evacuated. Unfortunately, in this most recent hurricane event, they did not have that capability. So there were so many people stuck in traffic. And I think this is going to be our future, to be able to leverage the video surveillance, the wireless communications to avoid traffic congestion, to be able to detect and automatically allocate contraflow or extra lanes on a freeway or a highway. And of course, reduced our storage costs by 50% with good old Zipstream, which allows us to pack in even more video streams in that wireless gigabit network. That geofencing is very important, and we're working on it. This is something that I believe is going to happen in the very near future, and it's going to happen independently of the social media platforms, because what will happen more and more is these sensors, the camera sensors and the wireless sensors, will be able to have the geolocation built into them so that it's not going to be dependent on the platform. What you're seeing here is a geofencing platform that actually shows some camera assets on the ground and might show the power of embedded audio analytics, which can have gunshot detection and verbal aggression and run it directly inside of there. Another solution that we will be deploying as a pilot project is a ballistic detection, and this is a very interesting one. This was used in Operation Iraqi Freedom, and it was actually it's actually able to deliver the ballistic information of the caliber of weapon that's used, plus the trajectory, and automatically move the pan tilt zoom camera over to the area. It's called Eagle, E-A-G-L. And by the way, any of this information, you're going to see a lot of interesting takeaways in the handouts, including the digital video handbook, plus some really cool videos like what you're seeing right now. This shows you what we call Zipstream, which is known as a next generation codec, which allows us to get anywhere from 50 to 80% increased savings through analyzing the scene in real time and then applying this most significant areas, the best compression in real time to the most significant areas, and also making sure you don't have a smear from an oncoming headlight, which is pretty amazing in this day and age. That type of thing is very, very important because it could totally obscure an image. The traffic incident management aspect is so very important, and it does contribute to safe cities. But the deep learning platforms, or the ability to utilize kind of a self-tuning environment, is really one of the biggest advantages of using deep learning, which is the next step after AI. So in other words, with a deep learning environment, you might have built in a learned traffic flow. And when a traffic incident occurs, the system will actually be able to analyze whether that incident is normally occurring with that type of traffic flow and provide a potential for a predictor. So over to you, Alex.
Hang on one second.
Thank you.
Want to ask one more poll question real quick, Alex.
Yeah, that's a great point. Thank you, Jim.
Yeah.
No problem.
So let's see. Bear with me a second. Oh, no. What did I do? Sorry, guys.
That's all right. We'll talk a little bit about
Yeah.
how we deployed this, right, Alex? One of the interesting things that we wound up doing was being on the rooftop, right, of the Four Seasons Hotel, and you were texted a picture of yourself by somebody that was looking at you and Jack on the roof, right?
Right.
Do you remember
right. From the 911 center? Uh-huh. Yes. Yeah. I know. It was a great deployment, you know, streaming that video back from the Four Seasons Hotel down in Discovery Green with all those tens of thousands of people there, creating a lot of, you know, wireless interference, everyone with their cell phones, etc. But you know, it worked perfectly, you know, during the whole event. So I know Houston PD was very pleased and very impressed with the performance of the system.
Absolutely. In fact, they knew who you folks were, but their SWAT team was all surrounding you, and just wanted to let you know that they knew that you were there, so that they were on the job, which was kind of cool. We got some good pictures of you folks up there. But you know, the difference is this wireless infrastructure, the use of the wireless infrastructure is really fantastic. And one thing that Alex, you can talk about is your ability to be sustainable on your wireless, right? You can actually be powered by PoE and also power PoE devices.
Right, we provide PoE pass-through in our radios, which basically means that you can connect a couple of cameras directly to the radio and have the radio power the cameras directly without without the cameras requiring additional PUE injectors. So in that way, the radio is acting like a switch as well as a power source for the cameras, which basically means you only need one Cat6 cable going up to the radio, providing power both and data obviously both for the radio as well as for the cameras you've got connected to it. So it makes the installation a lot easier. I just want to mention as well, kind of going back to the question on the hurricane, obviously devastating for the city, and we're all thinking about the people living and working in the city. But we're kind of waiting for the calls to come in from the city requesting assistance to get their communication network back up, because a lot of their communication infrastructure will have been damaged by the hurricane. Particularly fiber would have been flooded, would have been cut. So we know there's going to be a big requirement to get that back up and running, and they're going to be using quite a bit of wireless, I'm sure, for that. Not just for the video, but overall for connectivity and helping get the city back up and running.
That is so true. It's such a great technology for both quick deployments plus sustained deployments. So you can essentially have a wireless fiber going to an inaccessible area and then branch out from there.
Yeah, exactly. Tim, how you doing with the poll? You got it up?
We're going to pass that right now. So you're going to go ahead. Keep going. Having a little problem with the poll, so go you. Sorry.
All right, no worries. All right, just trying to.
I like it when you say that, Alex. Now. No worries. Yeah, you're always. How about if I admit it? Yeah, you're great that way.
Tim, so I'm just trying to advance this slide. For some reason, it's not advancing now. I don't know why I lost control of it or whatever.
Click on the screen first and then advance it.
Yeah, that's what I'm doing. That's what I'm doing.
Well, just tell me where you want to go.
Just advance for me. Yeah, if you want to advance it for me, for some reason it's not doing it before.
Sure. Just tell me when.
Yeah, go ahead. Go advance.
Oh. We there? No, it's not going.
Nope.
Yeah, so while waiting for Tim, while Tim is
waiting for that to. What I was going to talk about really is those cyclists. The part we play, we played a very important part of the Houston Super Bowl deployment, and that's basically on the connectivity side. Oh, there we go. It looks like we're back on track again. Yeah, so Ciclu, we're basically a connectivity provider, if you like. So when it comes to connectivity in a smart city, there's obviously a number of choices that can be made, and fiber is the obvious choice and the best choice if it's available. But the question is, is it available? And for example, the case of the Super Bowl, they wanted to put cameras on the top of the Four Seasons Hotel, but they had no way of connecting fiber up there to bring the video back, which is why they looked at using wireless. Some of the disadvantages and drawbacks of using fiber if it is not available is obviously the availability of it, the cost of deploying new fiber. If it's not available, it can be horrendously expensive. You're having to dig up the street, for example, and also the disruption that causes, as well as the time to deploy. If you're limited in terms of time scale to deploy fiber, then that might mean that it's not an option from a connectivity point of view. So wireless can be a very good alternative to fiber, either as an extension to existing fiber, or even as primarily a fiber-like infrastructure, which you can deploy to support it could be the video surveillance network or anything else that you want to put on there. But it does have a number of challenges with it, and traditionally, that was a little bit too quick. Let's go back up again. Traditionally, there are some disadvantages or drawbacks of wireless, and these include things like low bandwidth, for example, and that becomes more and more important, particularly now with the advent of high definition, high resolution cameras, 4K, things like that, multi-sensor cameras, which do require high bandwidth. Also, the reliability of the wireless network. due to concerns about congestion and interference, and that was one of the concerns they had at the Super Bowl, for example, with tens of thousands of people there, all on their smartphones, etc., creating a lot of disturbance, if you like, in the wireless spectrum, and a lot of interference. Ongoing maintenance, and again, supporting the wireless infrastructure. Issues with latency and jitter and losing packets of video, which can be very, very important, particularly if it's a critical video which may be lost. And the last one, really, security. How secure is that wireless network in terms of hacking and protection of the data? So these are all kind of concerns that IT managers in particular have when it comes to wireless, and particularly in a smart city type deployment.
Actually, Alex, you're the only wireless provider that has the highest level of encryption, right?
Exactly. Siklu utilizes what's called 256-bit AES encryption on our Etherhall series point-to-point radios, which is the highest type of encryption you can get. And not only that, but point-to-point using very narrow beam angles means that the actual data is very secure anyway, because it's not broadcast widely, so you just can't see it basically, unless you're literally between the radios using the same type of frequency, which I'll get onto in a minute. But it's a very, very secure network, and which is why a lot of city IT managers love this type of technology that Siklu uses, millimeter wave wireless, because of the security of it.
Yeah.
So one of the things I know, Steve, you mentioned, which I thought was very, very good, is really the whole aspect of smart cities is not just about video surveillance, but there's so many different sensors now being used as part of a smart city deployment, which is one reason why it's called smart cities as opposed to just safe cities or public safety. Video surveillance is just one aspect of it. There's license plate recognition. There's all types of sensors. It could be detecting pollution levels or weather. It could be audio. It could be SCADA. It could be a whole host of different types of applications, all running on the city smart city network, if you like. And all this type of traffic needs to be obviously supported from a networking point of view, which can be very, very challenging, particularly in the city, which may not have a huge source or availability of fiber, where again connectivity comes into play. So the type of wireless that Siklu provides, and this is only really been available in the security industry for the last 2 years or so, is what's called millimeter wave wireless. So really what we do, we take the benefits of fiber, very secure network, a lot of capacity, and also the benefits of legacy wireless in terms of low cost, time to deploy, very quick to deploy, without the drawbacks or disadvantages of each type of connection into our type of solution, if you like. So it's still wireless, but we also draw a lot of the benefits of fiber, which is why something Steve, you mentioned in your excuse me, in your presentation, what we did in Houston is, we like to call it fiber-like wireless, because it draws from both the benefits of fiber and wireless. It's immune to interference. It's very quick to deploy, very secure, which we talked about already with the encryption. It's low cost, much lower cost than deploying fiber, for example. With very low latency, so it's ideal for video, particularly if you're doing real-time situational awareness, PTZ control, for example. And important now, particularly if you're doing a large-scale camera deployment with, HD 4K cameras, multi-gigabit capacity. So no longer limited in terms of bandwidth, if you like. So lots and lots of bandwidth. Ideal, what you need basically for a smart city type deployment.
Hey, Alex, quick question for you.
Mm-hmm. Go ahead.
How does millimeter wave compare to 4.9 gigahertz public safety band? Pros and cons.
Yeah, great segue actually. So this next slide actually kind of talks about what millimeter wave wireless is, where it sits in the frequency range, if you like, and including 4.9. So I'll kind of I'll answer that question as I kind of go through this slide and talk about 4.9 as well as all the other frequencies. So this kind of chart shows you what the different frequencies are at the bottom in terms of gigahertz. So it's kind of split into 3 sections. On the left-hand side, you've got the unlicensed bands, what we like to categorize as the sub-6 gigahertz bands. And then in the middle, we have the 6 to 42 gigahertz licensed bands. There's a couple of license-free ones in there as well, but most of them are licensed and pretty expensive licenses. And then on the right-hand side is millimeter wave. So millimeter wave, that's the technology where Ciclu plays, and there are a number of other manufacturers in this space as well, but Ciclu is the only one in the security market. These are the 60, 70, 80 gigahertz frequencies, okay? And they're both license-free. 60 gigahertz is license-free. 70, 80 gigahertz does require a license. And these are all country-specific, but it's a very low-cost license. For example, in the US, it's only $75 per link license for a 10-year license. So very, very, very low cost. Now 4.9, excuse me, plays obviously in the sub-6 gigahertz band, and obviously that's a government controlled license primarily used for public safety. And you know, it's outside of the Wi-Fi spectrum. You know, it's not used by Wi-Fi, which is 5.4, 5.8 typically, as well as 2.4. So you could say it's more secure and not as congested, excuse me, as your 5.x type frequencies. However, the drawback of 4.9 is still it's very limited in terms of spectrum. So there's very, very little bandwidth, if you like. So if you're just, you know, running, you know, some cameras across it is not so bad. But if you're using it potentially for, you know, 911 communication, potentially running a whole city wireless network across that, you know, you could potentially run into problems of capacity, capacity as well as interference. And typically, you know, you'll use 4.9. Exactly, it's so crowded. And you know, we actually have a number of cities where they're actually replacing some of their 4.9 gigahertz frequencies with 60 gigahertz because of those issues, you know, of it being so crowded and limited in terms of bandwidth. To give you an idea, the amount of bandwidth in the 60, 70, 80 gigahertz is more, the amount of spectrum, shall I say, is more than all the other frequencies put together. There's roughly about 24 gigahertz of spectrum available in millimeter wave, which is more than all the others combined. And what this allows us to do is provide very high bandwidth. So in the 60 gigahertz, you know, and what we did in the city of Houston, for example, we're providing a gigabit throughput. In the 70, 80 gigahertz, we can deliver currently up to 5 gigabits per second, also 10 gig radio. So, you know, a very large pipe, if you like, for a very, you know, high amount of traffic, high amount of data. And also the millimeter wave frequencies are outside of the 5.4, 5.8 Wi-Fi spectrum, so we don't have any type of issues with interference or congestion. So you can use millimeter wave in the most crowded cities. So, for example, our radios are used in virtually all the large cities in the US, bar one currently, and with no problems with interference. You don't even have to do a spectral analysis with millimeter wave. The only thing you do have to do is you have to make sure you have clear line of sight. It won't go through walls or through trees, but no spectral analysis is needed because there's no interference issues. Okay, so hopefully that answers that question.
It's kind of like the difference between the F train in New York City and Japan's bullet train, right?
Yeah, pretty much. Yeah, exactly. Yeah, one's very, very slow and maybe not so reliable. The other one is super fast and extremely reliable. Exactly. Really, the key things to remember about this technology is there's only really, you know, 3 or 4 things. The first 2 are the most important. You know, the first is there's no interference or congestion at all. So you don't have to worry about how reliable is this network going to be. You know, am I going to install a wireless-based video surveillance network, and is it going to potentially, you know, fail on me because, you know, my neighbor puts in a Wi-Fi network, which could bring it down. It's not going to happen with millimeter wave. Another key one is multi-gigabit capacity, as I mentioned, up to 10 gigabits per second currently. And that's probably going to go up next year. A third one, which is very important for video, another reason why Axis, likes this type of technology is the low latency. They actually use this type of technology for high-speed trading on Wall Street. That's how fast it is. It's actually faster than fiber. So it's very, very low latency. So it's ideal for situation real-time monitoring. The one limitation of the technology is the distance. It's not designed for long range. So it's not a long range wireless product. It's really goes up to about 3 miles or 5 kilometers with clear line of sight. This is ideal in a city type of application where you're going, rooftop to rooftop, street light to street light kind of thing, as opposed to running from one mountaintop to another mountaintop, So it's more designed for a short, medium range as opposed to very long range. Okay. So one thing we often get involved in, this is a very good example also of what we did in Houston, where we were working closely with Verizon, for example, which was providing the fiber infrastructure. Is often, you'll get in a city, a small city, you get a hybrid fiber wireless type network. So part of it is running on fiber, whether it's fiber available under the street, either it's owned by the city or it's dark fiber where it's being leased by the city by a provider. And those parts of the city which are not connected by fiber, basically they're deploying wireless. So it could be, one rooftop or one building to another building at street level where they're connecting cameras. So actually the edge, if you like, where they're putting in wireless. So then really what you've got is a hybrid network, which is run on both fiber as well as wireless. And that's a good example of what they're doing in Houston. So from a wireless point of view, this is kind of traditionally what it may look like. So you could have, for example, a parking lot. It could be a school campus or a hospital or even a commercial type application or city hall, where, they have maybe fiber connecting buildings together, fiber to the building, but they don't have fiber to the actual lampposts where they have the cameras connected. Or they could be emergency call boxes. It could be Wi-Fi access points. Whatever it is, and running fiber under the ground could be very, very expensive to deploy. As long as they have power at the location where they want to put the edge device, the sensor, the camera, for example, running wireless to those locations is a much, much more affordable, lower cost, and quicker to deploy type solution than trying to do it over fiber. You could also be connecting different buildings together, municipality buildings, for example, libraries, schools, city hall, etc., police department, things like that, as opposed to doing it via fiber.
In which case, the fiber infrastructure is dictating the topology, which is the exact opposite of what a smart city should be doing. The city should be dictating the topology so you can leverage the millimeter wave and support any number of topologies.
Right. I mean, the key thing is, not where do I have fiber. The key thing is, where do I want to connect? Where do my connection points need to be? Where do I need to deploy my cameras, my sensors, whatever it is? Then it's a case of, okay, how is the best way of connecting those devices together? Where do I have fiber? Most cities will have a map of where their fiber is located, and which areas do I need to bridge with a wireless connection, as opposed to extending the fiber, and putting wireless is said far more cost effective and can be done much, much quicker. And that's actually a good example of what they did in Fort Myers. And it's kind of sad that the two case studies we're using today, and this is not done on purpose, both suffered from major hurricanes over the last literally 2 weeks or so. Fort Myers in Florida was hit pretty badly as well. Also we all know what went on in Houston. So Fort Myers in Florida, this is another project that Siklu did with Axis, another very, very successful project. And this is a very good example of a wireless type deployment. So this project came about as a result of a deadly shooting in October 18th, 2015, so almost a couple of years ago. They had an annual event there called Zombicon, and they had a shooting which went on there. It's actually a little video running. I don't know if you can actually hear it or not. This is someone just took the what went on with their camera. Anyway, someone actually got killed, unfortunately, as part of this, and there was no actual video footage of the perpetrator, if you like. There are no cameras around, and as a result of this, the city decided they had to deploy very, very quickly a state-of-the-art video surveillance public safety system. So they could give them better control, better visibility of what's going on in the downtown area. They had a number of issues or challenges to face. They only had about 60 days to actually have the system implemented. They had very limited fiber infrastructure, pretty much only on the perimeter of the downtown area, not within the downtown itself. They had mounting restrictions. They basically could only mount the cameras and any other devices onto 14-foot city-owned light posts, not onto any buildings. They couldn't mount any of the cameras on any private buildings, and they also had some line of sight issues for any wireless solution from things like palm trees, vehicles, and other kinds of obstructions.
Hey, Alex,
quick
question, Alex. In terms of other challenges, did power be a challenge at all, or was power a challenge at all in that deployment?
In certain instances, it was. Yeah, in certain instances, it was. Fortunately, they were drawing power off the lampposts, which the city owned. So, the city was able to provide power to the cameras. And in most instances, I think actually in all instances, they had continuous power at the lampposts. So certain lampposts don't have continuous power. There's only power at night when the lights are on. Basically, it's all centrally controlled. But in this instance, they did have continuous power, which meant it was feasible to do it. So yeah, that wasn't too much of a challenge from a power point of view, fortunately. Yeah.
Okay.
So Ciclu worked in partnership with Access on this project with the integrator company called A+ Technology out of Long Island, New York. Milestone and a company called IP Video Corporation were the VMS and the storage management platforms being used, and then the consultants company called True Security Design. So the whole project was designed within about 4 weeks, and it was actually implemented within less than 6 weeks, actually being about 4 weeks actually installed, which is pretty amazing. And what they actually did is they used Ciclu wireless throughout the downtown area, connecting to 2 fiber points, one being the harbor side and one being City Hall. And this kind of map shows you actually what the wireless network looks like. So the blue points on the map are one of the top harbor side and one on the bottom with the fiber locations. All the orange lines basically is the wireless network with the red dots, lampposts with cameras and wireless radios on. And we actually created a ring type architecture with redundancy, which basically meant if there's any kind of break in the wireless network in one location due to, for example, a high-sided vehicle interrupting the link, automatically would fail over to the other side. So they actually had a true redundant wireless network throughout the system. And what they actually deployed then at each pole location, if you like, they deployed 2 Axis Q3709 multi-center cameras. These are pretty hefty 33 megapixel cameras, as well as a PTZ camera for situational awareness. And then 1 to 3 Ciclu radios on each lamppost, basically connecting them all together. The actual throughput per pole was over 70 megabits per second. So they needed a very beefy, really a gigabit solution wireless network to deliver all this throughput, and the only type of technology available for them to use was millimeter wave wireless. They could not do this using a conventional, sub 6 gigahertz 5.4, 5.8 type wireless solution, because the maximum type of bandwidth they'd get would be about 100 megabits per second, which would be nowhere near sufficient for multiple poles being connected together.
It's amazing that the size of your units is so much smaller than what people normally expect. And it's even going to get better, right, Alex?
Yeah, that's right. The size is really, well, the size and performance is such a powerful radio in such a small package. And you said, the size is continuing to shrink, and the fact that it doesn't even look like a radio, it's going to look like more like a junction box or a square box. And that's actually one of the reasons why they chose Ciclo as well, because the aesthetics, it wouldn't kind of be too obvious. You can see it on the lamppost, and you can obviously tell the time of year. It was just before Christmas, and in fact, it was finished just before New Year's Eve at the end of the year. So none of the reasons why they chose Ciclo was because of the throughput capability, gig throughput, the interference-free 60 gigahertz band, which they could use, which is also license-free. The security side of it, using the encryption, and which we already mentioned, the very small form factor. So at the end of the day, they deployed a number of active cameras. I think it was over 100 sensors, and they were very, very pleased with the image quality. No jitter, real-time video. They're able to use the cameras at the maximum resolution. 33 megapixel, for example, at full frame rate, because they're 4K cameras over a wireless connection. You could not do that with any other type of wireless technology. You could only do that with millimeter wave. So the project summary was said 114 video feeds, 52 wireless radios. They built a whole new command and control center, in fact, two of them, one of the police station, plus another one of the situational command room, and 288 terabytes worth of storage. And this is all installed within about a month. 4 weeks. So it was very, very impressive what they were able to accomplish. And they could only have done it using wireless solution. They could not have done it using fiber or any other type of technology. So that was my bit, Tim. Back to you.
Yeah. No, you guys did an excellent job. We've answered all the questions that came up. So I just want to thank you guys for your time. Your contact information, I think I have it in here. Let's see. Here we go. Here's for Steve Safaro. This will be available on MP4 video starting tomorrow at 1 o'clock at the same site. So do know that it's been recorded and will be available for you. But there's
and Tim, I want to just mention one thing, if I could, that the Security Industry Association has really got some great members, and we're looking forward to new members and new participants in the public safety working group. So please feel free to shoot myself, Alex off an email, Tim, Mia. Actually, you could just send it to Mia, right? And we'll get you signed up and in the public safety working group. So you'll get an opportunity to participate in some of these projects, but also to make a real important contribution to standards in the industry.
Yeah, so Steve, I have a slide up that has the safety working group information, and it has to contact Ron Hawkins at SIA. So that's there. Again, this will be in your video. Here's Alex's contact information. And don't hesitate to contact these guys if you have any questions whatsoever. You can still send questions through the platform, and I will forward them to Alex and Steve. But again, thank you for joining us today. And Steve and Alex, thank you for your time. I really appreciate it. Our next webcast is actually going to be this coming Thursday, which is a Leadership Talks program, which is a weekly program starting this Thursday, going on weekly, and it's talking to leaders in the industry. So join us for that. Guys, thanks very much, and you all have a great day.
Thank you, Tim.
Thanks, Tim.